In the world of AI, there's a reigning heavyweight champion. For years, the transformer architecture has just dominated, well, everything. But now, a new challenger called Mamba has stepped into the ring. And it claims it can fix the one massive problem that's been holding the champ back. So let's break down this battle of the AI architectures. To really get why Mamba is such a big deal, we have to start by asking a pretty tough question about our current champion, the transformer. With all its power, why does it have this fundamental flaw when it comes to remembering long sequences of information? The answer, and this is the crazy part, lies in the very thing that makes the transformer so powerful in the first place, its attention mechanism. Turns out, its greatest strength is also its biggest weakness. Let's dig in. Okay, to get this, picture a dinner party. The transformer's self-attention is like forcing every single person at the table to have a one-on-one conversation with every other person before anyone can understand what's going on. Now, on one hand, it's super thorough. That's the power. But as you invite more guests, the number of conversations just explodes. That's the problem, a computational cost that balloons quadratically. And believe me, this isn't just some theoretical problem on a whiteboard. When you're trying to process a really long document, or a super high-res audio file, or even map a whole genome, that quadratic scaling becomes a huge real-world bottleneck. It just eats up memory and processing power like you wouldn't believe. So, how do you fix a problem like that? Well, you don't just try to build a bigger dinner party. You change the rules of the conversation completely. And that's where Mamba comes in, with a totally different design. Mamba is built on this thing called a state space model, or SSM. Now, unlike the transformers, everybody talk to everybody chaos, an SSM works step by step. It looks at one piece of data, updates its internal memory, which is like a compressed summary of everything it's seen, and then just moves on to the next piece. The whole process is actually pretty elegant. Think of it like passing a note down a line of people. Each person reads the note, scribbles down their own quick summary, and passes the updated note along. It's fast, it's efficient, and it definitely doesn't require everyone to talk to everyone else all at once. And here's the punchline. Mamba's computational cost grows linearly, not quadratically. What that means is, as the sequences get longer, the resources it needs grow at a way slower pace. This is the whole promise of Mamba, a massive leap in efficiency. But, does it actually work in the real world? To find out, researchers set up a direct showdown documented in a paper called Mamba in Speech. And they chose an incredibly tough arena for this fight, the world of speech processing. They tested the models on two really different tasks. The first was speech enhancement, which is all about taking noisy audio and cleaning it up. The second was automatic speech recognition, or ASR. Taking spoken words and turning them into text. And this is where the story gets super interesting, because the result wasn't a simple knockout punch. No, it was more like a tale of two completely different fights, with two very, very different endings. So, in the first round, speech enhancement, Mamba just lands a decisive blow. The data shows that the XBM Mamba 5 model, which has about 4.5 million parameters, consistently scored higher on quality than the bigger Transformer 6 model, which has almost 5 million parameters. So, better performance from a smaller model. That's a clear win for Mamba. But then comes round 2, speech recognition. And, well, it's a complete wipeout, but not in the way you'd think. A standalone Mamba model got absolutely demolished. Its word error rate, where lower is better, was a jaw-dropping 37.2%, while the transformer-based conformer was cruising at 6.5%. I mean, it wasn't even close. So what on earth just happened, right? How can one architecture be so amazing at one speech task and just fall flat on its face on another? This is the central mystery we have to figure out. And here is the big aha moment. The two tasks are fundamentally different. Speech enhancement is about spotting low-level patterns in the audio itself, things like static or a background hum. Mamba, with its super efficient linear process, is amazing at that. But speech recognition, that requires understanding high-level stuff, semantic information like grammar, context, what words actually mean. And on its own, Mamba's compressed little memory state just struggles to hold all that rich global context that the Transformers dinner party approach is so good at capturing. So, is that it? Is it game over for Mamba? Well, not so fast, because this is where the researchers had their most brilliant idea. They asked, what if this isn't a competition? What if it's a collaboration? Instead of just tossing out the entire transformer architecture, they did something like a surgical transplant. They took the big, powerful transformer model and they replaced its most expensive, power-hungry component, that quadratic self-attention part, with the lean, efficient Mamba engine. And the result? This incredible hybrid champion they called Connects Bimba. And get this, the new model didn't just match the original transformer in speech recognition, it actually beat it. And because it was using Mamba's efficient core, it was faster to train, faster to run, and it was way more stable, especially when working with smaller datasets. So in the end, the ultimate winner wasn't Transformer, and it wasn't Mamba. It was an alliance of the two, taking the global picture brain of the Transformer framework and powering it with the linear efficiency of Mamba. And this brings us to the really big picture. What does a stunning result like this mean for the future of AI? Is this just a one-off trick, or are we seeing a major shift in how we're going to build these models from now on? This quote from an online discussion just nails the fundamental trade-off we've been talking about. The Transformer's brute force approach lets it see everything, but it costs a fortune. Mamba is incredibly efficient, but its compressed memory means it might lose some of the fine details along the way. And that really is the ultimate takeaway here. This story might be signaling a change in the whole philosophy of AI development. Maybe we're moving away from this search for a single, one-size-fits-all model and moving toward a future of specialized hybrid systems that combine the strengths of different architectures to create something way better than the sum of its parts. Which leaves us with one final, provocative question to think about. As we keep pushing the limits of what's possible, is the next generation of AI going to be designed by a single dominant champion, or will it be built by a team of highly specialized components, all working together in a powerful new alliance? The answer to that could very well define the next decade of artificial intelligence.